forget that the formative is due tomorrow. That was page, I want to say 472 out of your textbook. Or out of your, I should say textbook, because it's really not a text. More just of a disposable or consumable textbook. So, 472 due tomorrow, beginning of class, skipping the recursive column and going just to the other three columns. Okay? Homeworks will be due on Friday this week. Okay? Make sure you're doing those the day that we assign them, not waiting until Thursday to get them done. Okay? Okay? So, a couple of those are my two reminders for today. Okay? First warm-up problem. Arithmetic or geometric? Geometric. Geometric. Why is it geometric? Negative 1/2, multiplying by negative 1/2 every time. So that to me says geometric. Okay. So then we can figure out, now that we know what our R is, we're multiplying by negative 1/2 every time. So let's find the next two terms. So negative 4 times negative 1/2 is 2. 2 times negative 1/2 is negative 1. Okay. Then it said write an explicit formula for it. Well, that would be G sub n equals G sub 1, which is negative 16, times R, negative 1/2, to the n minus 1 power.
Does it always have to be multiplication for geometry?
Yes. Yep. Because if it's adding, that's arithmetic.
Yeah, I just divided by negative 2.
Oh, okay. Yeah. Well, that's dividing is multiplying by the reciprocal.
Oh, okay.
You know what I mean? So multiplication and division are linked, and we just call it, technically we just call them multiplying. Adding and subtracting are linked, and technically we just call that adding. So, yeah. Yep. Then it said find the seventh term using the explicit formula. So then that would be G sub 7 is going to be negative 16 times negative 1/2 to the 7 minus 1 power. 7 minus 1 is 6. So that's going to be negative 16 times negative 1/2 to the 6th power is going to be positive 1/64. So that's going to be negative 16 over 64, which reduces down to negative 1/4. Okay? Prefer fractions there, just so you're a big fan of the fractions. We could have also just continued the pattern 2 more times, because we already had the first 5 terms of the sequence. Okay? So if we would have extended this out 2 more, we would have gotten negative or positive 1/2 there, negative 1/4, and then that would have been the 7th term in our sequence. Okay? Questions on that one? Okay. Second one, arithmetic or geometric? Arithmetic. What is my common difference then? So D is 8 there. Okay. So then the next 2 terms in the sequence would be 25 here and 33 there. Okay. Explicit formula then would be A sub n is equal to negative 7. Well, come on. I don't want you. There you go. negative 7 plus 8, because 8 is my d, times n minus 1. Okay? Now, if I made that look nice and pretty, okay, so then that would be like negative 7 plus 8n minus 8. So we could have also said 8n minus 15 there as my explicit formula. Okay, because both of those are the same. That's fine too. Okay, just distribute in the d and make that all nice and pretty. Okay. Then it said find the 40th term. So, oops. A sub 40 is going to be negative 7 plus 8 times 40 minus 1. That's going to be 39. $39 times 8 is 312. 312. $312 plus negative 7 then is going to be 305. Good with that? Okay. These are sequences. Okay? We can handle sequences. Okay? Sequences are separated by commas. Today, we're going to shift our thinking from sequences to series. Okay? The difference between a sequence and a series is that with the series, we're taking the sequence and we're adding it up. Okay? That's all we're doing. We're taking our sequence, adding up all the terms, and then that's how we find the series. Okay? So it shifts the look, okay? The look, the touch, the feel of cotton, okay? Shifts from commas in between each term. Okay? In both of these, there were commas in between each term. Now, in a series, we have addition signs in between, and that's how you write out a series with addition signs. Okay? Back when I was in college, one of the very first math classes that I took in college, in 110 Vincent Hall on the campus of the University of Minnesota, go Gophers, okay? Which the room is still there, but looks totally different. I just walked in this fall when I was on campus for a while. The professor saw that one of the non-traditional students in the class had brought their, I think it was daughter. This was 20 years ago, so okay, brought their daughter. And anyways, and they were sitting right up front. So the professor wanted to not be distracted, or have the kid not have something to do and cause a disruption in the class. So the professor stopped, went to the child and said, "You know the numbers? You know all the numbers 1 to 100?" The kid's like, "Yeah, I do." "Do you know how to add?" Yeah, I do." So the professor said, "Add up all the numbers 1 to 100." Okay? So I'm telling you right now, add up all the numbers 1 to 100. Okay? Would take you a long time, right?
Yeah.
Okay? But Chuck, or Carl, I should say, not Chuck, Carl, so good to see you. He said, Carl Gauss said, he had the answer like that. Okay? The answer is 5,050. The sum of the first 100 integers is 5,050. Okay? What number are you on, Jacob? 17. Okay? All right? So, what Gauss did was Gauss saw that if you took the first number, or the first term, and you add it to the last term, then you add the second You kind of link these two together. Then you add the second and the second last. I went a little too far. Got a little crazy. Then you add the third and the third last. Fourth and the fourth last. And you work your way in from the outsides. Right?
That's kind of cool.
What do you notice about all of those groupings?
It's always 101.
It's always 101. All the groups add up to be 101. Okay? How many groups are there in this particular example? There's 50 of those groups. Because if you've got 100 digits and you're adding 2 of them at a time, that means you're going to have 50 groups. With me? So if I've got 50 groups, all adding to be 101, all I've got to do there then is take 50 times 101, which is 5,050. Okay. Now, let's translate what Gauss did into a formula. Okay? So Gauss said that the sum was equal to what? How did we get this 50 number right there? The number of groups that we had, right? And how did we get this 101 number?
That's what every pair adds up to.
So that's the total of each group, right?
Yeah.
Okay. Alright, so we're there. Okay. Now, let's try and get some more math going on into here. Okay. How did Gauss know that there was 100, so that there were 50 groups? How did he know that there were 50 groups?
Each group has 2.
Okay, because each group had 2, and then
It was half of the last number.
half of the last number, right? But this just so happened to be that there were 100 numbers in this series, right? Okay, so that means that there's 100, the T word, terms in this series, right? Okay, so this would be the number of terms divided by 2, right? And then he found the first term plus the last term, right? Right? Now, from your extensive knowledge here in chapter 6, do we have a symbol for the number of terms in a sequence or series? No. What? N. Okay? So the number of terms is N. Divided by 2 is divided by 2. Do we have a symbol for the first term?
A1.
A1 is what I put on my steaks. Makes it taste nice.
A of 1.
Not A of 1,
A sub.
A sub 1. Yep. Do I have a symbol for the last term in my series? is, what did you say? Say it louder, Mark. A sub n? Yep. And that is how we find the sum of the first n terms. We reserve capital S for sum. Okay? Thinking way outside the box on that one. Okay? So this is Gauss's technique to find the sum of any arithmetic sequence. Okay? Now, with that technique comes a couple of conditions. Okay? First off, you got to have three things. First off, you need the number of terms. Right? What else do you got to have?
Starting number in the sequence.
Your first term. What else do you got to have?
The last term.
Got to have the last term. Now, for sure, you will be given at least two of those. Okay? Because I can't give you just the first term and say find the sum. You know what I mean? Okay? So you're going to be given at least two of those. What happens if you don't have the third one? What happens if we're missing one? Do we just punt?
Didn't you solve for
What?
Did you solve for A1?
What do we call A of n is a formula or is a function notation. What do we use if we don't have one of those terms?
A variable.
The what? The recursive formula. What is the recursive formula for an arithmetic? A sub n equals I guess you'd know this by now. A sub n equals A sub 1, or we want to use recursive, we want to use explicit. Yeah. Plus D times n minus 1. Yeah. Yeah, because we're not using recursive, we're using explicit.
Yeah, that makes sense.
Okay? And then we can use that to find whatever we're missing. Okay? Let's put it to work. So, that's my first term. That's my last term. What's my total number of terms? How many terms are there in this series? 6. Okay, you can count them up. Okay. Now in number 4, you can't count them up. So then you might have to do some extra work there in number 4. Okay. So with that being said, then the sum of the first 6 terms of this series is 6 divided by 2 times 39 plus 4. 6 divided by 2 is 3. 39 plus 4 is 43. 3 times 43 is 129. Quick check, because there's only 6 terms. 4 plus 11 is 15. Plus 18 is 33. Plus 25 is 58. Plus 32 is 90. Plus 39 is 129. So it works out. Okay? You now do 2, 3, and 4. While you guys are finishing up number 4, I think everybody's pretty much on number 4. I'll catch up. There's a sub 1. There's a sub n. And there are 1, 2, 3, 4, 5, 6, 7, 8 terms. So S sub 8 then is going to be 8 divided by 2 times 12. Oops. Plus 40. So that's going to be 4 times 52, which is 208 for number 2. Agree? Okay. A sub 1 A sub n equals 5. Odd number. A sub 5 then is going to be 5 divided by 2 times 10 plus 30. That's going to be 5 divided by 2 times 40, which is, well, no, now. Let me, all right. Which is, hold on, I get rid of it, now, there it goes. Now I can move it down. Which is,
100.
yep, so 5 times 20, which is 100. Okay. Ruh-roh, I know what A sub 1 is. I know what A sub n is. But do I know n? Don't know it yet, right? So A sub n is equal to A sub 1 plus D times n minus 1. A sub n is 2. A sub 1 is negative 16. What's my common difference? Adding 3 every time. Add 16 to both sides. Divide by 3. So 7 is my n. So the sum of the first 7 terms is going to be 7 divided by 2 times negative 16 plus 2. So that's 7 halves times negative 14. So that's positive 7 times negative 7, which is negative 49. Yeah, buddy? Okay. Big question of the day. Does Gauss's technique work for odd numbered and even numbered series? Yep, you betcha. whichever one your preference is. Okay? Handle? Difference between sequences and series?
One is comes with this.
Which one?
Series.
Series has additions, and what do we do with those addition signs? What do we do with those addition signs in a series? You add them up, right? Okay? You add them up. You do that adding. Okay? So, now I'm going to blow your minds. Okay? Because there's something out there called sigma notation. Okay? Sigma notation is, you've probably actually seen it before. And I'll show you where you've seen it before. Well, that's not clear at all. We'll go halfways in there. Okay? Here, I'll show you where you've seen it before. You've seen it before. Right here. Okay? Okay? Sigma notation you've probably seen when you use Excel documents. It's the sum. Okay? So sigma, okay, is a common math term, okay, or a common math symbol. It's the big old E. Okay? That's how we write sigma. And what it means is you're finding the sum. Okay? That's what sigma notation means. Now, there's 1, 2, 3, 4 parts that go around the sigma that we're going to explain right now. Okay? The first part is what is technically called the index of summation. Okay? The index of summation is simply a variable. Okay? It's a variable that gets used in the rule. So your rule that comes after the sigma notation had better have the same variable that you're using as your index of summation. Okay? Then there's going to be a number. And that number, the first number on the bottom, is called the lower bound. Okay? It is not your first term. Okay? It is not the first term. What you do with the lower bound is it's a number that you plug in to the rule to get your first term. Okay? So whatever number is below your sigma, you plug that number in for that index of summation into that rule, and the result there then is your first term. Okay? That's your lower bound. The top number is your upper bound. It's the number you plug into the rule to get your last term. going back to Gauss, do we have a way to find the first term? Yeah, take this bottom number, plug it in, that gives us our first term. Do we have a way to find the last term? Yeah, top number, plug it in, gives you your last term. Okay? And then the shortcut to find the number of terms, n, okay? N is going to be your upper bound minus your lower bound plus 1. So it's top minus bottom plus 1. Okay? Let's put it to work. Now, I carefully selected here example number 1. Okay? I so carefully selected it that it's the same example number 1 that you just did at the top of that page. Okay? That's the sigma notation to go along with that example. Okay? So the answer should be 129. Okay? So, to find the first term, I take 1 and I put it into my rule. 1 minus 1, 0 times 7, 0. 39 minus 0, 39. So my first term is 39. Did everybody see how I did that? Okay. My last term, a sub n, I plug in 6 in for I. 6 minus 1. Jacob? 6 minus 1? 5. Okay. I thought you said it. Okay. Okay. Times 6? 30. 39 minus 30. 9. What else do I need?
Your number, no.
What else do I need?
Last term.
Just found the last term.
Number of terms.
Number of terms then, right? So the number of terms is my top number minus my bottom number plus 1. So that's 6. Okay? So the sum of the first 6 terms is going to be 6 divided by 2 times 39. Hold on, not 9. That shouldn't be 9 there. It should be 4. Because it's
because you didn't multiply it by.
I did 6 instead of 7. That's where I screwed up. Right here. Yet you guys were all sleeping and didn't even catch it. And 39 plus 4 is
43.
43. 3 times 43 then is 129. So the sum of the first 6 terms is 129. Okay? You do 2, 3, and 4. So I got 208 for number 2. Agree?
Yeah.
Hmm?
There's What's that same sign right at the bottom here?
Sigma right here?
Yeah.
That one? It's my math type. Yep. So that's, again, common math symbol. For number 3, I got 115. For number 4, I got 1,584. Make that 15 look good. Questions on that? Okay. Fantastic. Okay. A military band marches in a formation consisting of 8 rows. Okay. The first row has 2 band members, and each successive row has 3 more band members than the previous row. Okay. Question number 1 says, write an arithmetic series. Okay. So series says what?
Addition.
That means that what goes in between each term? Addition goes in between each term. If it said write a sequence, then it's commas. Okay? So, what is the first row? How many band members are in the first row? 2. Then, second row. 5. Third row.
5. Wait. 8.
8. Fourth row.
11.
Fifth row.
14.
Sixth row. Seventh row. Eighth row.
22.
Ninth row.
There's only 8 rows.
What, Ben?
There's only 8 rows.
So do I have to go any further? No. So I stop. Okay, stop at 8. Okay. Then it says, find the total number of band members marching. Well, my first row has 2 people in it. My last row has 23 people in it. My total number of rows is 8. So the sum of the 8 rows is 8 divided by 2 times 2 plus 23. That's going to be 4 times 25. So there are 100 band members. Okay. Now, in regards to question number 1, if I gave this as the answer, is that correct?
No.
Okay, because that's a sequence, right? But can I find the sum? Can I add up all the terms of that sequence? Yeah, and then I would still get 100 band members. Okay, but write it in series notation. That means I have to write it in the blue form, not the green form. I can still get the sum from the sequence, okay, but it's technically a sequence, not a sum. Okay. Now, the challenge is rewriting that series 2, 5, 8, 11, 14, 17, 20, 23 as some kind of sigma. Okay? Try it. See what you come up with. I'll give you a couple of minutes just to try it. I don't expect you to get it, but just try it. First thing we got to do is we got to pick a variable. What variable you want to use? Z. Okay. So we'll use Z. Oops. Oh, now. Z. Okay. Where are we going to start Z? 1. Okay. Where are we going to end Z? 8, because there's 8 rows, right? Okay. Now we just got to come up with a rule that involves Z. Where do you think we can come up with a rule? Ben, you better not be packing up.
I'm not.
Where do you think we can come up with a rule? Right? Okay. What's my first term? 2. What's my common difference? 3. Oops, that should be minus 1, not whatever it was that was. So is that a rule? If I plug 8 into that rule, do I get 23? Yeah, so there's my rule. Except I'm going to switch n to z because that's what variable you said we were going to use. Okay? Now, if I went a little further, if I go half of a step further here, and I go, well, this is 2 plus 3n minus 3, so that's 3n minus 1, right? Okay. If I go half a step further there, then my formula, my sigma, if you will, would still be from 1 to 8 of, now it would be 3z minus 1. These are both the same thing. Now, I gave you a yellow homework sheet. It's not due until Friday. But when should you do it? Tonight. This afternoon or tonight. There are some trick questions on there. This I know because I've already had to answer one of the trick questions, or people came in with questions already on it. Okay? We will go over that tomorrow in class if you do it. If you don't do it, we're not going to go over it. Okay? Stay current with your homework. Okay? Formative assessment 472 is due tomorrow.